if we have learned every other concept about an AC circuit, and we have not thought of understanding what power and power factor in an AC circuit is all about, that means we have learned halfway. We need to learn this concept in full, and that is what we're going to do today. Right? So without wasting time, in an AC circuit, there is some amount of power being dissipated by these components, okay, in the circuit. And that's what we're going to take note of. How do we do that? The average power expended in an AC circuit is stated as P is equal to I V cos phi. Take note. Take note of this. In every situation or question given to you, the average power across an AC circuit is stated as this. But what we need to understand, what are the meanings of these individual components, parameters, so to say. Now, the first one is I. I is the effective root mean square current of the circuit. Excuse me. V is the same thing, the effective root mean square value of the voltage of the circuits. And we have cos phi. Cos phi is the power factor of the circuits, which I'm going to explain in detail in the course of treating this topic. So let's pay attention. So what are we trying to do here? Very simple. If we have understood this, then we are making progress. So what do? Let's first of all understand where this power is being wasted or is being dissipated. All right? I'm going to take it one at a time. What pure device is all about. So we're going to look at the component that takes the power when some amount of voltage is supplied across the AC circuits, the component that consumes power or consumes more of the energy, so to say. So let's begin with number one. That is why I didn't clean it, because I know I'm still going to make use of this. The first one is the resistor. Of course, the power here is P is equal to I squared and then R. So what could be the power here? This could be just simply P is equal to I XL by the time we find the inductive reactance. That's what it means. So we may not have any problem here. And then we have here P is equal to I, if possible, this is to be squared as well, squared, and then XC if we find the capacitive reactance. But there is no need for all this. The reason is that the inductor does not consume any power. The capacitor does not consume any power. It is only the resistor that consumes the power that flows, or the energy that flows into an AC circuit. Take notes. So if you are given a question that contains these three components, and you are asked to find the power, just the power, not the power factor, use this. When you use this, you will get the answer correctly. If you apply any of this, because no power is consumed here, no power is also consumed there, even if the three components are connected, still take note of R, because that is the only component that absorbs much of the power or much of the energy or much of the current flowing through the circuits. Take note of that. Very, very important. If we have understood this, of course, we have understood something important. It is time for us to look into what power factor is all about, and how to know when a device is a pure device or not. So we need to do that. So let's begin with power factor. Cos phi. Cos phi. This factor, this phi varies between 0 and 90 degrees. Between 0 and unity, I mean, not 90 degrees, between 0 and unity is 1. Alright? So when it varies, it goes up from 90, goes down to 0 again, and then we have certain factor. But what happens here is this. If we have this at this point, there is no power. And this can only happen when we have L and C connected, or even R. Alright? That's the excess. But a device that has its power factor 0, this, if the device power factor is 0, take notes. That is cos phi is 0. That device is a pure device if its component is a resistance, an inductance or inductor, and or a capacitance or capacitor. When it is 0, it means it is either a pure resistance device or it is either a pure inductance device or it is either a pure capacitance device. That's what it means. That is when the power factor is 0. Okay? Then if the power factor is 1, there is a kind of in-between. It could be this, it could be that, but there is a kind of in-between. But a pure device must have its power factor 0. If it is 1, that means there is a big question mark as to whether the device is a pure device or not. Take note. So if we have this, then it is very simple for us to calculate what power factor is all about. What power factor is all about? We can now calculate that cos phi is equals to R over Z. Okay? R is the component that takes much of the power flowing through the circuit. That is the resistor. Then the Z is the total opposition of phi when these three components are connected in a circuit like this, in series connection. So we find the impedance. The impedance is Z. And both parameters are measured in ohms. If we do this, we have succeeded in calculating the power factor. So that's what it means. If we take note of this and apply it while solving any question, we will arrive at a concrete answer. And that is all. So take note of this. All that I've said. That the main component that takes current in an AC circuit, that absorbs much energy in an AC circuit, is the resistor. These ones, they don't take much of the current at all. Maybe because of their nature. Of course, what is this? This is just a coil. What it does is to produce some amount of magnetic field, because it's a coil that might even offer some more opposition, just small amount of opposition. And this one, the same thing, stores current, stores energy in its electric field, so they don't consume it. And look at this. This is a super resistance. It takes all. The power belongs to it. That's what happens when a resistor is connected. I am signing out. But hold on, please. Hold on, please. Maybe you have not subscribed. It's time. Come on, subscribe. You have not put on the bell button. It's time. Put it on for constant notification. You have not shared. It's time. Share. Come on. Share. Give to everybody. Come on. I am out. Dr. Kingsley talk.